So there is linked answer questions. The second question is based on the answer of the first question here. Clock cycles required for add and multiplication instructions are respectively 1 and 3. So for add instructions, clock cycle is one cycle. For multiplication instruction, 3 cycles. A program consists of 20 add and 10 multiplication, MULT means multiplication here, instructions. Frequency f is 1 gigahertz. What is the average CPI? CPI means clocks per cycle instructions, clock cycles per instruction. So there is a formula for this. Average CPI is equal to number of add instructions into clock cycles required for add. Say for example 20 add instructions. How many cycles are required for add? 1. Plus how many multiplication instructions? There are 10 multiplication instructions. Each multiplication instruction takes 3 cycles divided by total number of instructions including add and multiplication. 20 add plus 10 multiplication, total 30 instructions. So this 20 is the number of add instructions, this 30 is 10 is the number of multiplication instruction, this 1 is the cycle for each add, 3 is the number of cycles for each multiplication divided by total number of instructions, both the addition number of instructions in a program. So this will be equal to 20 plus 30 divided by 30, it is 50 by 30. So it is equal to nearly 1.67 cycles per instruction. So this is CPI 1.67. So option B is the correct option. So using this answer, there is some linked question, that is determine the execution time of the program. Determine the execution time of the program. Option A is 25 nanoseconds, B is 66 nanoseconds, C is 93 nanoseconds, option D is none of these. So we have to determine the execution time of a program, total program. The program contains 20 add instructions and 10 multiplication instructions. Frequency is also given as 1 gigahertz. So if you want to find out a total execution time, we have to make use of the CPI. So 1.67 you have to make use here. So the execution time formula is, execution time it is the average CPI what we got in the previous case, average CPI into total number of instructions. Total number of instructions divided by the frequency f. So that is anyway in the gigahertz only we take. So average CPI is we found as 1.67 cycles into total number of instruction is 30 divided by 50. Is not 50, divided by frequency is 1. So that it is nearly it is 50.1. Since it is gigahertz, it is nanoseconds divided by per second only. This will be taken for second, that's why cycles per instruction. So this for gigahertz it will be nanoseconds, 50.1 nanosecond. So no answer, that is 25 is not there, 66, that 93. So none of this. Option D is the correct option here.
Question: a directed graph is given. We have to apply Diksha algorithm to find the distance between the shortest distance between pair of vertices, and it is also given that S contains initially vertex A. This is the statement for linked answer questions. The given graph is the statement for linked answers questions. And in the first question, we have to find the order of the vertices in which they are included in S finally. Initially, S contains vertex A. So we have to find distance from A to B, from A to C, from A to D, then A to E. So here, if we observe the graph, distance from A to B is 1. So here we'll write 1. There is no edge between A and C. So here the distance will be infinity. And the distance between and there is a edge from A to D. So and the distance is 3. So here we'll write 3. And there is an edge between A and E, direct edge, and the distance is 10. So here we'll write 10. So here the shortest distance, here the shortest distance is A to B. So we'll add, so we have to choose the next vertex as B. So if we proceed, so here we will be getting 1, and here from B to C there is an edge which is of distance 5. So from A to C the distance will be 1 plus 5, which is 6. So here we can, now we can reach C here. So this distance from A to C would be 6. So we write 6 here, and this is the minimum cost, so we won't change this one, and this would be minimum cost. So among these, the next shortest distance is to vertex D. So here we will add D. So if we proceed like this, we'll be getting as 1. Here we can reach vertex C from A to D, which is of distance 3, and from D to C. So here the cost would be 3 plus 2 5. Earlier distance was 6. So here the minimum distance would be 5. So we will replace 6 with 5. So this would be same, and this would be 9. Here why 9? The reason for 9 here is because we can reach vertex E from A through A to D and D to E via D. So the total distance would be 3 plus 6, 9. So which is smaller than the earlier one. So we will replace 10 by 9. So if we proceed, and here the next vertex we should add is A, B, D. So here the cost of C is less. So the distance to vertex C is less. So we will add A, B, D, C, C next. So if you proceed like this, we'll be getting as 1, 5, 3 and 6. Now the last vertex is E. So we'll add that also. So the correct order of vertices in which they are added is A, B, D, C, E, which is option C. The second question for the same data is, if array D holds the shortest distance from source to each vertex, then what is D of E? So if we observe this table, we will be getting D of E as the shortest distance. So here D of E is 6. So the cost, so here D of E is nothing but 6. So here the correct option is option A.